Hi, my name is Jane Pauling, and this is the Physics 2212 Lab 1, Charge Tapes. The purpose of this lab is to observe Coulomb's law in action, as well as analyze the concept of charges and how they affect each other and their surroundings. We will do this by creating a real-world example of this effect using charge tapes. While conducting this experiment, I observed that the tapes were attracted to my hand, and because both tapes were attracted to my hand, it makes sense that they would repel each other. And when testing this came out to be true. The tapes were also attracted to neutral objects, which I believe is due to the polarization of the neutral objects. The tapes were also attracted to a negatively charged pen, and through this, I can safely conclude that the tapes are both positively charged. Through my data collection and calculations, I found that the length of the floating tape is 0.165 meters, and the mass of the floating tape is the density times the length of the tape is 0.00165 kilograms. Through this free body diagram that's on the left-hand side, you can see that the force of gravity and the electric force are the only two forces acting on the floating tape. The force of gravity can be found by multiplying the mass of the tape times the acceleration, which is 0.00165 times 9.81, and that comes out to be 0.00162 newtons. The distance between the floating tape and the electric field source, the other tape, the other charged tape, I found the distance to be 0.02 meters. And as you can see from the free body diagram, the force of gravity and the electric force point in opposite directions, and the sum of forces has to be equal to 0. Therefore, the electric force is equal to the force of gravity. Using this calculation and the formula, the magnitude of E is equal to 1 over 4 pi epsilon naught times Q over the magnitude of R squared. It can be found that Q is equal to the square root of mg times R squared over 1 over 4 pi epsilon naught. And after inserting the variables that we have found already, Q can be found to be 8.48 times 10 to the negative 9 coulombs. In order to find the number of electrons on the tape, we took the total charge and divided it by the charge of the electron. So 8.48 times 10 to the negative 9 divided by 1.6 times 10 to the negative 19 comes out to be 5.3 times 10 to the 10 electrons. And while being given the diameter of the atom 1 times 10 to the negative 10 meters, we are able to find the number of atoms in the tape by dividing the length of the tape by the diameter of the atom. And this value comes out to be 1.65 times 10 to the 9 atoms. And to find the ratio of electrons to the number of atoms, we divided the number of electrons by the number of atoms, and this comes out to be 32.12 excess electrons. We are able to make this calculation by assuming that there is one valence electron per atom. On this coding slide, you can see how the force diagram is shown for both charged particles. The orange arrow represents the electric field created at that location by the other particle. The cyan arrow is representing the force of gravity on each charged particle, and the green arrow is representing the net force on both particles. Notice how on the blue particle there is no green arrow because the sum of forces on that particle is equal to 0. In conclusion, I believe it is safe to say that the charge on both U tapes is positive. The electric field created by the red particle on the blue particle is 1.908 times 10 to the 5th newtons per coulomb, and the ratio of excess electrons on both tapes is 32.12 electrons. I would also like to make a note that there may be some error or variation in the electric field due to human error in recording the distance at which the top tape begins to float. Questions. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? Well, if electrons had positive charge and protons had negative charge, the entire system would act exactly the same as it had in this experiment. If the pen, instead of being negatively charged, suddenly became positively charged, and the positively charged tape suddenly became negatively charged, they would still be attracted to each other. And the same goes for my hand. My negatively charged hand would still attract the positively charged tape if the charges were flipped. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? It is important to handle the charged tapes as little as possible because every time your hand or other objects makes contact with the tape, the charges on the tape spread out throughout the object that it's in contact with in order to reach equilibrium. So if you continue to handle it excessively, then the tape will no longer interact with your hand or any of the other objects that it's in contact with because now it has no charge.